David. Welcome to ESC Boston. We're glad to have you here.
Thank you.
So tell us a little bit about the LPC1100 Design Challenge. What was it that made you enter the contest, and how did you feel it went, and what was your experience with it?
It was really quite amazing. Generally I do software engineering and systems engineering kinds of things, but I read my EE Times absolutely religiously, cover to cover, just because I was in a double E many years ago. And on the second page I saw this, what can you do with 65 cents? And I thought, that's pretty interesting for a byline, so I read it a little bit more. It talked about the LPC challenge and an idea that I'd had for some time, getting to think about it a little bit more. It was kind of interesting to see how technology has evolved now, where a 32-bit micro, 50 megahertz, with all this memory and peripherals on board, can be sold so cheaply at 65 cents. Now granted, it's 10,000 piece quantities, but I'm sure you can work deals and get them for $1 or so for lower quantities. But no, it's really kind of an amazing performance price point that we've now hit. And I think that this is really a hallmark. And I saw also that the M0 family, the Cortex M0 family, was kind of new, and it was really exciting.
Very good. Well, tell us a little bit about your experience working with the 1100 and the Cortex M0 core. We'd like to know a little bit about how you thought the peripherals worked well with the core, and what your overall experience was.
Well, I have to admit, this was the first time I did an I2C design. I'd learned about I2C many years ago and the SPI interfaces, but I'd never actually done a design. I'm from the old school where we'd have an address and data bus, and we'd get our wire wrap tools out, or we'd just have to wire these things. So it's kind of interesting, and that was one of the nice things too, is that I started looking at some of the I2C peripherals that I would need to do something like my project, and saw that basically everything that I needed was either an I2C or SPI. So it seemed like a really easy way to get into the contest and get some development tools. And as far as my experience goes, it was pretty easy. You'll see that there's only 3 parts on there, and there were either, well, 4 parts including the micro SD, and they were either SPI interface or I2C, so it was pretty easy to put it together. I loved it.
Very cool. So speaking of your design, tell us a little bit about what inspired you to do this type of design, and a little bit about how it works.
I'd seen something similar to this before, so I can't claim that I invented this variometer idea that talks to you. Somebody else in Europe, won't mention the name, came up with the idea, and I thought it was kind of neat. Now, granted, this one's a little bit fancier and it's higher precision, but the idea came from the fact that I fly remote control gliders a lot. I love flying remote control gliders, and looking at some kind of display to tell me how fast the airplane's going up or down in a thermal wouldn't be a good idea, so I needed something to talk to me. And it will tell me how fast it's going up or down and what the altitude is, but I've also added in the battery voltage. It will tell me, if I've been flying for a long time, it'll basically tell me, hey, you're getting to the end of your battery, time to come home.
All right, David, so I got to ask you, we love this design, but the name is so unique and so cool as well. Can you tell us a little bit about, first of all, what the name is for those who haven't heard, and how you came up with the name?
Well, the name is Bitchin' Betty, so you got to be careful how you say it, because there's 2 different ways to say it. Like, I grew up in California, Southern California, so they like total bitchin', like Bitchin' Betty. It's probably the preferred way to say it. Or you can say bitchin' as in, well, I won't go there with my, brings back memories of my mom telling me I'm late for dinner. But no, the idea is that fighter pilots, when they're flying, they'd found out some time ago that they respond really well to a woman's voice. And if they're so involved in what they're doing and they're flying their airplane, they forget about whether they're low on fuel or they're about to run into a mountain. So they have a voice that will say, terrain, terrain, pull up, and it's a female voice. And that's what the fighter jocks have named it, Bitchin' Betty. So that's where the name came from. Very
cool.
Yeah.
So have you used this a lot with any of your personal gliders, or have you had a chance to test it out yet?
Well, it's actually kind of a funny story. When I entered the contest, I had built a plane special just for the contest that had the right size to fit the walkie-talkie equipment in there. I have some higher performance planes that the walkie-talkie just won't fit in. But I built this plane, and the weekend before I was going to do the video, I had a little accident and I crashed it. So the plane that I had in my video was my daughter's trainer plane, and it's actually kind of a funny personal story in my family of making the video using my daughter's trainer plane. So you'll see in the video.
Very good, very good.
It was fun.
Well, can you give any advice to some of our customers out there that may be kind of wavering on a decision whether to move from an 8-bit product to a 32-bit product? So we have a lot of them that are still using 8-bit design, and those are great products, but we think they should move to 32-bit, but we'd like to hear your opinion on it.
I can't imagine what's holding them back. I mean, for the price performance these days, there's no excuse. There's no reason to stick with, the older stuff. The 32-bit ARM-based architectures are fantastic. They give you the power. It's, again, 50 megahertz and up from there. Programmable phase lock loops for your peripheral buses, depending upon what you need, and the kinds of peripherals that have been chosen for this low-end family is just unbelievable. It's the kind of stuff that most people need to do the kinds of applications for general purpose kinds of computing or embedded applications.
Excellent.
A lot of goodies there to do what you need to do.
Right. Well, we just recently, as of today, announced a new design challenge with our embed tool, still using a Cortex product, Cortex M3. Are you planning to enter that contest? Are you excited about that one, or you need some time off?
I'm not going to tell.
Oh,
for my future competitors out there, we'll see.
Very good.
Sounds
very
like
good.
fun, though.
Well, Dave, we really appreciate you being here. Is there anything else that you wanted to add or say about the demo or the contest or how your experience went with us?
I just really want to thank all of the supporters and the ARM, NXP, EE Times, and DigiKey. I mean, it was a lot of fun, and the other competitors too. They were all great, and I think that I can't wait to see what you've got for Embed.
Excellent, very good.
Again, thank you.
Thank you.